Welcome. In this video I'm going to show you how you can perform a likelihood ratio, also known as a g-test of goodness of fit, using Python and my stikpetP library. I'll mainly be going over how you can actually get the output, not so much if you should be using this test or how to read all the output exactly. I'm using Jupyter Lab and Python version 3.97, but this should work in any IDE, or at least the code should. So to show you how this works, I actually need an example. So I'll import pandas so I can read a CSV file, GSS 2012, which is short for General Social Survey. I actually don't need all this data. I actually also adapted it slightly. The only field I'm actually going to be needing is the marital status. That's the one I'm going to be using as an example. And just to give you a quick impression, so I used the values count. So there were, for example, 314 people who indicated to be divorced. Now my library, the stikpetP library, can be loaded from GitHub. So don't just only use pip install and then stikpetP, but just use this whole line, because I haven't put it up on wherever it is you need to upload this. So it's just on my GitHub account. Then you can import it just as any other library. The function takes 3 arguments, or 1 has to and 2 are optional. The data, of course. If you like, you can give it some expected counts, and if you want, you can use a continuity correction. Now let's take it for a spin. You simply fill out the formula or type the name of the formula, give it the field that you're interested in, and it spits out a nice little table with some results. The N is of course the sample size, the K is the number of categories, the statistic is the chi-square value, or G value in this case, the degrees of freedom, which is simply K minus 1, the p-value, also sometimes referred to as the significance. It also shows the minimum expected count. If you don't provide it with expected count, it's simply taking the sample size divided by the k. Then it's the same for all of them, and that's why the proportion of cells with an expected count less than 5 is actually 0. It also shows you the test that was actually used, and in this case that's a g-test of goodness of fit. If you like I mentioned, you can actually also provide it with some e-count. So I'm doing that here. And then I can use that, and let's also add a continuity correction. And there we go, we get the results. I have a separate video on this, on how you can do similar things with the SciPy library, using the power divergence function there. And there's a little bit more if you just want to go over the entire formula itself, or if you want to also know a little bit more about those corrections. Note that the Yates continuity correction is usually only reserved for 2x2 tables, so only if you have 2 categories, but the Williams correction and the E.S. Pearson correction, and of course the references. Alright, I hope this was helpful, and thank you for watching.